Hello and welcome to this presentation about characteristics of data and information. The intended audience for this is Year 11 and 12 students in VCE Computing. I just want to make a quick point of clarification. I also have a presentation called Factors Affecting Quality of Data and Information. This is not an overlap or a duplicate. This is a different topic, and I'll go on and explain what the difference is in just a tick. So, our learning intention is that students can identify and explain the characteristics of data and information. There are 6 characteristics that we're talking about today, at least I hope there's 6. So, what's the difference between talking about characteristics and factors affecting quality? Well, the characteristics are descriptive. So when we're saying here is some data, or datum, I think, I can't say I've studied Latin at school, but it was so very long ago, I'm just going to say data. It's descriptive. This is what this data is, and when we're talking about factors affecting quality, we're understanding why we should treat specific data with caution, and probably also an understanding of why we should treat data in general with caution. But this presentation, just about the terms that we use to describe data. So, if you were here in the room with me, I'd be asking you which ones you all ready to remember. I'm obviously not a great example of this, since I can't remember whether it's 5 or 6. I think it's 6. So there's the size. The size is pretty easy. That's just the size that it takes up in memory. It's the structure of the data, so we're 2. It's the relevance of the data. Now, relevance is also one of the factors affecting quality. So that fits into both presentations. The accessibility. Now, accessibility actually has 2 dimensions to that meaning. Clarity, so that's 5, and it is 6, is the context. So those are the 6 things we can use to describe data, and some of the descriptions are better than others. They're not value neutral. First of all, let's have a look at size. Well, the size refers to the amount of space or memory, and space or memory effectively, or space taken up in the processing of the computer, occupied by the data or the information. The most common way we say this is in terms of a file size. Sometimes it's a little bit complicated in that the operating system will report how big it is in terms of how big a block of memory it took, rather than how much actual memory it took. So it's a little bit like putting a house on a block. Sorry, I've got a catch in my throat here. It's terribly smoky, unfortunately. I'm recording this on a day when there's bushfires across Victoria, which is a terrible thing, and it's quite smoky. So it's like putting a house on a block. Once you put one house on it, it actually occupies the entire block. You can't reuse it with another file. So sometimes it looks a little bit unclear how much space something is taking. And it's typically measured in bytes and kilobytes, megabytes, gigabytes, and terabytes. For our purposes, most of the stuff that we're interested in are probably going to be measured in megabytes and gigabytes, although those other things certainly have their uses. So let's put your knowledge to the test. I actually struggled with this a bit. I've got the answers over on the other screen, which I might be referring to as we go along. Which of these files would typically be the smallest in size? A 3-minute MP3 music file, so that could be anywhere from a meg or 2. A plain text document containing 500 words, that'd only be a few K actually. A single high-resolution photograph from a smartphone, I reckon that'd be about the same size as a music file, and a 30-second video recorded in HD would actually be much larger. So the correct answer is B in that case. Actually, just looking back, what does it say? Yeah, 3 to 4K kilobytes for the text file. Says an MP3 3 to 4, yeah, photo 3 to 5, and it reckons a video could be anything up to 100 megabytes. So certainly not all files are created equal. Some formats take up a lot more data than others. Next one. Students need to email a file, but the attachment is 10 megabytes, or the limit is 10 megabytes, and that actually is the limit on my work system. Which file would they be most likely to be able to send? A 5-minute 4K video of their science experiment. Well, we know from the last question that's going to be much bigger than that. A PowerPoint presentation with 20 slides and a few images. I reckon they'd be okay there. A full album of 12 songs in high quality audio. Not a chance. They might get 4 songs, they might get 3. And a collection of 50 high-res photos from their phone. maybe 2 at high resolution. So the answer for that one is going to be B. I'll just check, and we are correct. Place these file types in order from smallest to largest typical file size. What I really like about this question is that sometimes with a multiple choice, which is a feature of the Unit 3 and 4 exam, you have to find the best answer, and sometimes you can just go through and rule out some of them. So a Word document with 10 pages of text and 2 images. Okay, so that, depending on the images, that could be anywhere from 500k to 10 meg. A full-length movie in standard definition, that's about 300 meg. An ebook novel in EPUB format is actually probably smaller than the Word document, would be my guess. And a video game installation file. Now that covers a lot of sins there. That could be anywhere from 200k to 2 terabytes, just because video games are so variable. So I'm going to work with the ones that I'm pretty certain of. So I think, before I even see the options, I think 1 or 3 is going to be first, and 1 or 3 is going to be second. So 1, 3, 4 and 2, 3, 1, 2 and 4. Okay, so in actual fact 3 of them start with 1 and 3. So let's have a look at 3. So 3 would be an EPUB, yep. 1 would be a Word document, yeah, I could buy that. 2 could be a movie, and 4, yeah, so I don't hate A as an answer. I'd probably pay that as correct. B is 1, yep, 3, yep, 4. Actually, I would accept I would accept any A, B and D on this. The correct answer that the AI has generated is C, but what's it saying? An SD movie is typically 1 to 4 gigabytes. That's not my experience of it. I'd pay A, B or D. I think that question, I might brush that up before I use that with my class. A USB stick has 8 gigabytes of memory. How many of each file types would you store? About 2,000 high resolution photos or 4 HD movies. Yeah, I reckon that's about right. About 4,000 plain to 8,000 plain text documents, or about 80 HD movies. I think that's too high for the HD movies. I don't think you'd fit them in. About 2,000 songs, or about 8 HD movies. C I reckon's believable. A or C at this point. About 8 video games, or about 8,000 plain text documents. And you know what? I'm going to edit this before I use this with my class. I think this is a horrible question. It says that C is correct, but it's so variable in terms of what you're using. So there you go. Let that be a lesson for me. So the next characteristic that we can talk about in terms of describing data or a file is the structure. So that refers to the organisation and arrangement of data, defining how information is formatted, stored and accessed. It's akin to being a data type, but it's not actually a data type. It's more about how the organisation is organised rather than how it's written in ones and zeros, but it's sort of like a cousin to a data type. So let's see what data types we can already name. I'm going to say plain text, CSV, XML, one-dimensional array, two-dimensional array, and records off the top of my head. So plain text, one-dimensional array, two-dimensional array, associative array or dictionary, I missed that. XML I had, CSV I think I had, and I forgot JSON. So all of those are different ways of doing it. So, and of course a relational database. I think I said that. So let's have a quick test and see if we can recognize some of these. So, which of the following is an example of plain text? Well, the answer to that is B, and that one, thankfully, is pretty straightforward. That one up the top, I think, is an associative array, then it's plain text, then it's a CSV, and then it's a CSV. So, what's the best example of a one-dimensional array? Oh, I can see it right there. A is the answer. B is just a standard variable, and I think that's a two-dimensional array. And that's certainly an associative array. So the answer there is B, is A. Best example of CSV. would be the C is the best example of CSV. It's got multiple lines, and you can in your head kind of line them up in columns using the commas. Which of the following is an example of a two-dimensional array? Well, that's just a plain old one-dimensional array. That's a two-dimensional array because each of the first dimensions has a second dimension within it. So that's a two-dimensional array. I think that's an associative array, and that's just a regular array. So our next thing is relevance. Now the image here is of the young woman wearing a weirdly private school top is looking at a math textbook and explaining this to the man who's fishing. It's not that the information isn't right, it's just that it's not relevant for our particular inquiry. So this is actually something which is also a factor affecting the quality. So there is some overlap here, and this is one of those points of overlap. We're looking for contextual significance. Is it significant in the context that we're interested in? If we're fishing, it's not that that data is bad, it's just that it's not relevant for our context. Is it timely? You know, am I looking at a maths book from 100 years ago, or for that matter 20 years ago? When I went to university, they used to talk about the half-life of your information, and that is how long it is until half of what you know is not considered valid anymore. Because particularly in scientific areas, the knowledge is moving quite quickly, so you can be out of date. You know, in computing, your knowledge can be out of date. You know, some of the stuff that I'm saying here will be wrong within the year, not in this particular video, I hope, but in the field of AI and what they call vibe coding, that's changing all the time. So your timeliness would absolutely be a factor. Accuracy for specific needs. Accessibility. Now, accessibility actually has two dimensions to it. One is how well can you access it, as in how accessible is it? If you put in your username and password, can you get to it? Is it physically accessible? You know, not everything is out there on the internet. There are things called Faraday cages where you can stop networks getting inside them, wireless networks in particular. You know, is it just physically accessible? Is it technologically available? Do you have the right permission to get to it? You know, is it accessible in that sense? Is it in a format that you can read? You know, it's less common these days, but there was a time when, you know, Windows and Macintosh computers read different sorts of files, and it was quite difficult to get them to read each other's files. These days, computers tend to be better about reading various formats, but there's something, I think it's an HEIC file, that I see being generated, and I don't know, I can't put my hand on my heart and swear this is true, but I have heard that you can't just natively open that on a Windows computer. And the second dimension is it accessible to a variety of people? Now, just, you know, publishing only English is reducing the accessibility of something. The language that you can use can reduce the accessibility. Now, everything doesn't have to be accessible to everybody else. It isn't about saying, well, your language, it needs to be in every language on earth. But that's the descriptor. We're saying, well, it's accessible to English readers with a high school education. It's a descriptor rather than a value judgment, although you can have a look at it and decide what's important to you and your process. So, here's a kind of thought bubble or thought experiment. Change just one thing about a library to reduce its accessibility. So if you're watching this, and I guess if you're watching this at home, if you're at school, if you're watching this on YouTube, what would make a library accessible? Well, if you couldn't get to it, if it wasn't organised enough for you to find the data you need, that's going to be an accessibility problem. If it's in a language you don't understand, if it's in a language that's too hard for you, if it's been taken out by somebody else and not available to you, that's going to reduce its accessibility. If the library's only open for an hour a day, if you have to pay to use it, if you had to be a member of the library to borrow it, all of these things would change the accessibility of that data. And the last one is clarity. Now this image I've got here I actually think is a terrible descriptor of clarity, because while it has clarity in that you can see clearly through it, I wouldn't know how to get data out of that mythical system there. Clarity means that it's easily understood, unambiguous and transparent in communication. People often criticise academic writing, and I think unfairly, for being deliberately unclear. I think people say that because they don't have the professional knowledge to understand all of the, what people would uncharitably call jargon or professional language that's in it. But this system here is actually a tremendous failure of clarity, because while they're grinning their heads off, you wouldn't know where to find information. It would look pretty, but it'd be quite unclear how to get the information that you needed out of it. So that's what we mean by that. That's, simplicity of language. Again, that's in context. Precision of expression. Can you just go, oh yeah, I know what that is? And is it organised in such a way that you can get to it? And I would argue that in that, fictional illustration, that's very hard to understand how you get data. And the absence of ambiguity. If you're reading something and you don't know, but from the way it's organised or expressed, what it means, then there is a problem of clarity with that data. And comprehensibility is basically the same. Okay, the last one is context. In what context is the information presented? And this gives me a chance to use one of my favourite jokes of this dog who walks into a Western saloon and pops its hand up on there and says, I'm looking for the man who shot my paw. So, in the context of this, we understand that it's, who shot my pa, and it's the accent doing the work. But you take away the context and the joke really doesn't work. So you can have temporal, time-related context. You can have location-related context. People talk about this all the time. Apparently in the United States, if you say somebody's quite pretty, that means that they're not quite pretty. That they're quite pretty. Whereas in Australia, if you say somebody's quite pretty, you actually mean they're very pretty. So in the spatial context, though that compliment actually means a different thing. And that's reasonably common for that to be the case. Cultural context is pretty much the same in that last example. Organisational context, people within particular organisations have terms, often derided as jargon, as I said earlier, but in a particular organisation, what you can say or what this information means can mean something different than it would mean in a different organisation. Likewise, historically, and that is the end of the presentation. So I hope that proved useful to you, and I'll see you in another presentation.